Hello friends, welcome to the MathNest YouTube channel. Today we've got a very challenging problem from the American Mathematical Olympiad. We've got two circles centered at O and Q with diameters of 6 and 18. They touch each other at point P. A red band and drawn tangent to the circles around them. The question asks for the length of the red band. Well, to solve it, we use mathematical theorems and simplify the problem for ourselves. First, we connect the centers of the two circles together. Since the two circles are tangent, the length of the line segment OQ equals the sum of the radii of the two circles, which is 3 plus 9, namely 12. Next, we connect the centers of the circles to the points of contact with the red ribbon. We denote these points as A, B, C, and D, as shown in the figure. It's clear that the length of these lines is equal to the radii of the circles, and at the point of contact, they are perpendicular to the tangent line. Therefore, for 90 degrees and angles are formed. So the length of the red ribbon will be equal to the sum of the arcs AB and CD plus the length of the line segment AD and BC. So we write length red ribbon equal arcs A B plus C D plus A D plus B C. To calculate A D, we draw a line parallel OQ from point A. You see which intersects the radius of the larger circle at point N. We know both radii OA and QD are perpendicular to line AD, meaning they are parallel to each other too. As a result, a quadrilateral OAQ Q is formed, where the opposite sides are parallel. Therefore, it is a parallelogram. O, A, D, Q. And the opposite sides are also equal to each other. A, N equal O, Q, then O, A equal Q, N. Exactly, the lengths of AN and OQ become 12, and the length of QN equals OA, which is 3. Therefore, the length of ND is equal to the difference QD and QN is equal to difference between two radii. 9 difference 3 equal 6. Now in right triangle, A, D, N, the sine of A angle is the ratio of opposite side and D over the hypotenuse A N. This result is ND 6 over the AN 12 1 over 2. Then the measure of A angle equal 30 degree. According to the theorem stating that the sum of the interior angles of the triangle is 180 degrees. The measure of N angle will then be 60 degree. I know angle A plus angle D plus angle N1, that side, equal 118 degree. We know 13 plus 90 plus N1 equal 180, then N1 equal 18 difference 19 difference 13. So N1 equal 60 degree. Additionally, the sine of 60 equal radical 3 over 2. And solving this equation, That's meaning we write AD over the hypotenuse AN equal radical free up to 2 AN 12, then AD equal 6 radical free. And the tangent line BC can be calculated in the same manner like AD. Then we can write BC equal 6 radical free 2. Now to calculate the arcs. According to the theorem of parallel lines AN and OQ and diagonal line DQ, we have an angle Q1 equal to angle N1, which means we can write Q1 angles equal 60 degrees. According to the similar solution, angle Q2 is also calculated to be 60 degrees. And we can write Q2 angles equal 60 degrees. Again, we're using the theorem of parallel lines and the diagonal. The angles Q1 and Q2 are both found to be 60 degrees. Therefore, the arc length AB. Again, we using the theorem of parallel lines and diagonal. The angles O1 and O2 are both found to be 60 degrees. We can write O1 angles equal O2 angles equal 60 degrees because we have a parallel and diagonal lines. Therefore, the arc length AB arc length become the product of two 60 degrees over 360 degrees multiplied by the circumference of the smaller circle. We can write arc AB equal to multiple the 60 degrees over 360 degree multiple the circumference 2p r, that's 3. Okay, we can simplify and end solution, that's 2p. In the larger circle we have a CD arc. We write CD arc equal to the ratio of the angle Q3 to the 360 degrees multiplied by the circumference of the circle. At first we calculate Q3 angle equal 360 difference Q1 angle and difference Q2 angle. That's 60 degree. That's 60 degrees too. The answer equal is 214 degrees. We write 240 over the 360 multiple circumference 2p multiple r is 9 equal 12p. Now we back to this formula. The length of red band equal arc AB. We calculated 2p plus arc CD. We calculated 12p plus line segment AD 6 radical 3 plus line segment BC 6 radical 3. 14p plus 12 radical 3. And the solution to the problem become 14p plus 12 radical 3. Thank you for joining me in this video. Please subscribe, and if you have any other problems you'd like me to solve, be sure to let me know in the comments. I'll see you in the next video.